3. Hidden Symmetry. In the previous scene, we discovered that every integer possesses its own geometric shell, a collection of points, each representing a different way of writing the same number as the sum of 4 squares. At first glance, these points may appear to be scattered at random, but mathematics rarely rewards first impressions. Rotate the shell. Look at it from another direction, then another. Patterns begin to emerge. Points align. Shapes repeat. Entire regions mirror one another with astonishing precision. This is not coincidence. It is symmetry, a hidden order woven into the arithmetic itself. The same number can be represented in many different ways, yet together, those representations form a single, coherent geometric object. The shell behaves almost like a crystal, not a crystal built from atoms, but one built entirely from numbers. As the integers grow larger, their shells become richer and more intricate. New patterns appear. Old patterns return in unexpected places. The geometry becomes increasingly beautiful. What began as a simple equation has become a landscape filled with structure. And symmetry is our guide. Because hidden within these shells lies one of the most remarkable objects in 4-dimensional geometry. A shape whose elegance has fascinated mathematicians for more than a century. The journey toward that shape begins now.